Now we are going to solve 2002 APMT problem. Diameter of human eye lens is 2 millimeter. What will be the minimum distance between 2 points to resolve them? What is the resolving power? This, see, if you are watching stars, they are looking like a point. But if you are watching a basketball, it is looking like a big sphere. It doesn't mean star is in size less than basketball. What you are observing depends on the angle which that object makes on your eye. So your eye has a limit. See, when a rocket is moving away from you, after some time it will look like a point. After some time it will disappear. It means now for rocket it is not possible to maintain that angle on your eye so that you can observe that. It was not a point. When you are seeing the rocket as a point, it is not a point. But due to a distance, you cannot separate 2 points differently. So every optical instrument has its limit of resolution. For human eye, we have the formula up to what distance you can see separately two objects. It is given by lambda d by d. For human eye, it is lambda d by d. In this problem, lambda was given 5000 into 10 to the power minus 10. D was given 50 meter and capital D, it was given 2 into 10 to the power minus 3 because it was in millimeter. So what we are getting in this for human eye, 5 into 5, 25 by 2, 12.5 into 10 to the power 336 and 17 minus 3 meter. But if you solve in centimeter, multiply by 100, what you will get? You will get in a centimeter 10 to the power minus 1. Means in centimeter it will be 1.25 centimeter. So we will go with C option. So 29th C option was there. Next, a telescope has an objective lens of 10 centimeter diameter and is situated at a distance of 1 kilometer from two objects. The minimum distance between these two objects which can be resolved by the telescope when the mean wavelength of light is 5000 angstrom. For telescope, this resolving power is, angle of resolution is 1.22 lambda divided by d. But what is angle? Angle is equals to distance arc upon radius. For it is your telescope and that object, it at a distance d. So they can make an angle on telescope. This is again theta. So theta you can get from this also. One formula is this and one you can get from this arc upon radius. So for this we can calculate y is equals to 1.22 lambda into d divided by capital D. For telescope it is this 1.22 lambda. What is lambda? 5000 10 to the power minus 10. What is distance? Distance is 1 kilometer, means 1000 meter. What is capital D? Diameter is 10 centimeter, means 10 upon 100 meter. Cancel this 0 with this 0. What we are getting? 5 to the 10. We are getting nearly 1.22 into 5. Light we are using 5000 angstrom. Diameter is 10 centimeter. Yes. So we will check what option we are getting. Nearly 1.22 into 5, 6.10 into 10 to the power 33617. Minus 10 means minus 3 in centimeter, multiply by 100. So we are getting 0.6 centimeters. Means nearly we are getting, multiplying by 1000 millimeter option is also there. So we will get nearly 6 millimeter. So nearest option is C. So we will go with C. So 30th, what we got? C option. Nearly C option we will get. Okay, distance between objects should be at least 6 millimeter. So we will go for 5 millimeters. Okay, all options are a big distance, mean tens multiples are there. 5 millimeter, 50 millimeter. So at a very big distance they are 5000 millimeters. So we will go with C. Next, 31st, Maxwell's equation describe the fundamental laws of both electricity and magnetism. 32nd, a parallel plate capacitor. 32nd, a parallel plate capacitor with plate area A and separation between the plates D is charged at a constant current I. Consider a plane surface of area A by 2 parallel to the plates and drawn between the plates. I told you that displacement current is equal to the conduction current. If conduction current is I, displacement current should be I. It was the results of Maxwell's experiments and the theoretical calculations. 33rd, an electromagnetic wave passing through the vacuum is described by the equation E is equals to E0 sin kx minus omega t and B is equals to B0 sin kx minus omega t. So what we know? We know that speed of light we can calculate by E naught by B naught. But what is speed? Speed is the product of frequency and wavelength. In this equation, what is k? In both equation, k represents 2 pi by lambda. What is omega? Omega is 2 pi f. So we can calculate the value of lambda and frequency. What is lambda? Lambda is 2 pi by k. What is frequency? Omega by 2 pi. So now we are putting the value of f. F means omega by 2 pi. Lambda 2 pi by k is equals to E naught by B naught. So what we are getting? Omega into B naught. It should be equal to k into E naught. So omega into B naught should be equal to E naught into k. So we will go with option A. Next, 34th. The amplitude of the electric field of a plane electromagnetic wave in air is given, means E naught is given. We want to calculate B naught. Just we have discussed one problem. what is the relation between speed of light and E naught B naught? C is equals to E naught by B naught. So B naught should be equal to E naught by C. In SI unit, E naught is given 6 into 10 to the power minus 4. In SI unit, speed of light is 3 into 10 to the power 8, and SI unit of magnetic field is Tesla. So we will get answer in Tesla. So what we are getting? 6 by 3 means 2 into 10 to the power minus 12 Tesla. So amplitude of magnetic field should be 2 into 10 to the power minus 12 Tesla. Next, 35th problem. A plane electromagnetic wave is given. We want to calculate the refractive index. What we know, with omega t, it should be omega. So omega is given 6 into 10 to the power 8. What is the value of K? K is given 4. K is given, omega is given. So what we can calculate? With omega, you are able to calculate frequency of light in this medium in which wave is propagating. 6 into 10 to the power 8. All is volt per meter means SI units we are using. With the help of K, you are able to calculate lambda. With the help of F and lambda, we are able to calculate speed in medium. V is equals to, and lambda means F into lambda. What is the value of F? 6 into 10 to the power 8 divided by 2 pi. What is the value of lambda? 2 pi by 4. So what we are going to get? 6 by 4 means 1.5 into 10 to the power 8 meter per second. It means electromagnetic wave in this medium is moving with this velocity. But we know that what is the refractive index of any medium? Speed of light in air or vacuum upon speed of light in medium. We know that speed of light means electromagnetic wave in air or vacuum is 3 into 10 to the power 8. What we are getting here? 1.5 into 10 to the power 8. So refractive index should be 2. So we will go with option B. 36th. The pressure exerted by an electromagnetic wave of intensity I on a non-reflecting surface is C is the velocity of light. What is the unit of I? We will go dimensionally for this problem. Unit of I is watt. Watt means power. Power means work or energy divided by time into meter square. What is work or energy? Force into displacement. But force per unit area, it is pressure. Force per unit area is pressure. And displacement upon time is speed. Speed is given C. So what should be the value of pressure? Pressure should be I divided by C. So we will go with option C. I divided by C. 37th. If C is the velocity of light, which one of the following is correct? I told you that speed of light we can calculate by 1 upon under root mu naught into epsilon naught. And if you want to calculate in any another medium, you can calculate by putting the permeability and permittivity of that medium means mu into epsilon. Or you can write it, if you know the relative permeability and permittivity, you can write it 1 upon under root mu naught epsilon naught mu r epsilon r. So these are very important results. So if it is C, C square should be 1 upon mu naught epsilon naught. So mu naught epsilon naught means 1 upon C square. So we will go with D option. 38. The electromagnetic waves having speed 2.5 into 10 to the power 8 meter per second are traveling in a medium of relative permeability 0.8. The relative permittivity of the medium is, we know that speed of light in any medium we can calculate by 1 upon under root, just we wrote the formula mu naught epsilon naught mu r epsilon r. We can do this like this, 1 upon under root mu naught epsilon naught into 1 upon under root mu r into epsilon r. It is C. So Cm is equals to C, speed of light in air or vacuum, upon under root mu r epsilon r. So we can see that under root mu r epsilon r can be calculated by C by Cm. Now everything is given, mu naught epsilon mu r epsilon r. So what is speed of light in air or vacuum? Light means electromagnetic waves, 3 into 10 to the power 8 meter per second. This medium they gave 2.5 into 10 to the power 8. By squaring both sides, we are getting mu r into epsilon r is equals to 3 into 3. Cancel 10 to the power 8 with 10 to the power 8 by 2.5 into 2.5. Now, relative permittivity of medium we want to calculate epsilon r, and mu r is given. What is given? Mu r, relative permeability 0.8. We want to calculate epsilon r. So we are putting the value of mu r, epsilon r we are getting 3 into 3 upon 2.5 into 0.8. Remove this decimal, remove this decimal, remove this decimal. You will get 1000. 25 40s are 1000. 5 5s are 5 8s are. Cancel 8 with 8. So what we are getting? 9 by 5 means 1.8. So we will go with option B. So B option was correct. 39th. An electromagnetic wave of frequency this from vacuum in a dielectric medium with permittivity 4. What will happen to wavelength? What will happen to frequency? We know that frequency is always unchanged. Frequency is always unchanged. And velocity of electromagnetic wave in any medium is given by 1 upon under root mu into mu, it means mu naught epsilon naught mu r epsilon r. So everything is given now. They gave us the dielectric medium with permittivity means epsilon naught into epsilon r, it is given 4. It is given 4. We are changing only that factor. From air, it is entering into this medium. So what is the effect of this? Frequency will be unchanged, but that 4 factor is coming now. It is speed of light. 1 upon mu naught epsilon naught means speed of light. We remove that. This is mu naught epsilon naught speed of light. Mu r into epsilon r. If we are entering in a medium of permittivity 4, so 2 will come out of the square root. If 2 will come out of the square root, speed of light will be halved. Frequency is not changed. But if speed is becoming half, speed is mu n into lambda. Speed half means, what is wavelength? Wavelength is c upon frequency. So if frequency is unchanged, c is becoming half, means lambda is becoming half. So with which answer we have to go? Wavelength half and frequency remains unchanged, because only one factor they are saying it is changing. Permittivity is changing and it is becoming 4 times. So we will go with option C. We will go with option C. Next, the RMS value of the electric field of the light coming from the sun is this. The total average density of the electromagnetic waves are. What is the formula for total average energy density? We know that it is given by epsilon naught into ERMS. ERMS. Now each and everything is given. ERMS square. It is E is equals to epsilon naught into ERMS square. It is the relation between the average energy density and RMS value of the electric field. So now in this problem we know the value of epsilon naught, what it is? 8.85 into 10 to the power minus 12. ERMS directly given 720. So 720 into 720. Since simple calculator is allowed, so we can use that. We will multiply first the given numbers. What numbers are there? The numbers are there only 8.85 into 72 into 72. So we are getting by these number 45878. We multiplied this and this. Remaining is 10 to the power 12. So what we are getting? 8.85 this. So we are getting into 10 to the power minus 12 and plus 2 minus 10. If we put decimal after point 4.5, 1, 2, 3, 4 zeros into 10 to the power, it will become minus 6. Unit joule per meter cube. Density means energy per unit volume. So we will go with option B. We will go with option B. 41st. In a plane electromagnetic wave, the electric field oscillates at a frequency is given. Amplitude is also given. What is the wavelength of the wave? What is the wavelength of the wave? What is the relation? We know that velocity is equals to frequency into wavelength. For electromagnetic waves, C, it is 3 into 10 to the power 8. Frequency they are saying in SI unit 2 into 10 to the power 10. So what should be lambda in meter? It should be 1.5 into 10 to the power minus 2 meter. What should be the value of lambda? 1.5 10 to the power minus 2 meter. Frequency was given. So it is very easy to calculate wavelength because we know the speed of electromagnetic waves. 42nd direct formula they are asking, the velocity of electromagnetic wave is parallel to, since it is perpendicular to both electric field and magnetic field, so it should be the cross product of these two. But take care, velocity is a vector quantity, so to whom we should write first? So we should write E first because it is equal to E cross B, because light is propagating in this manner. It means if electric vector is oscillating in x-axis, positive x-axis direction, and B is in positive y direction, wave will propagate in the positive direction of z-axis. 43rd, a point source of electromagnetic radiation has an average power put 1500 watt. The maximum value of electric field at a distance 3 meter from the source. What is the formula for intensity? It is P upon energy per unit area, power per unit area, P upon 4 pi r square. But one more formula we have, 1 upon 2 epsilon naught E square into C. So from this formula we are able to calculate this E naught. It is E square means amplitude of electric field square. So you can calculate E naught. How to calculate? Now first we will calculate E naught square. So what you are getting? 2 power, take this term on this side, 4 pi epsilon naught r square into C. Easy to calculate. Put the value of 1 upon 4 pi epsilon naught, 9 into 10 to the power 9. 2 is 2, power is in SI unit 1500 watt. What is R? Distance is 3 meters, so square is 9. You know the speed of light, it is 3 into 10 to the power 8. 3 into 10 to the power 8. So what we are getting now? Cancel 9 with 9. 3 into 1500, you will get 500. Cancel 10 to the power 8 with this 9. 500 into 2, 1000 and 10 this. We are getting 10,000. Now easy to take square root. E naught will become 100. So what we are getting? We are getting option B. 44th. The electric field of an electromagnetic wave traveling through vacuum is given by the equation this. The quantity that is independent of wavelength is, we know that omega stands for 2 pi into frequency. So omega alone is not independent of lambda because frequency is, what is speed? Speed is equals to frequency into lambda. So frequency we can write speed upon lambda. Again k alone is not independent of lambda because it is 2 pi by lambda. But if you divide omega by k or k by omega, this 2 pi by lambda will cancel out. So what we are observing, that k upon omega, it is given in option. So only dividing by omega upon k or k upon omega, both are independent of lambda. So we will go with option A. Next, an electromagnetic wave propagating along north has its electric field vector upwards. Its magnetic field vector point towards C. Now this formula will help you. That's why I was saying ki take care to whom we have to write first. The waves are propagating in the direction of E cross B. Means the speed vector is equal to E cross B. Now, we are making this north, south, east, west are given. East I am taking along x-axis. So, negative direction of x-axis west. North means positive direction of y-axis. South negative direction of y-axis. And positive direction of z-axis vertically upward. Downward means negative direction of z-axis. And we know the vector triode. I told you that if you want I cross j will give you k or j cross k, what it will give you? Write I, j, k in anti-clockwise direction on a circle and move along them. Product of 2 will give you third. It means product of I cross j will give you k. J cross k will give you I. K cross I will give you j. This direction is direction of unit vector I cap. This is the direction of j cap. Upward direction means positive direction of z-axis means direction of k cap. Now, E cross B. What is E? Direction of E. Electric vector in upward direction. Upward direction means k cross. What is the direction of B? We want to calculate the direction of B. But we know the direction of C. Electromagnetic wave is moving in north direction. This means you need J. So, k cross what should be J? K cross I is equals to j. So, it should be in the direction of I means positive direction of x-axis means east direction. So, we will go with option B. Ki magnetic field vector point towards east. So, 45th we got option B. So, it was the completion of our this unit. The name of unit was Wave Optics and Electromagnetic Waves. One question every year we are getting from this unit. Thank you.